YouTube is taking its time. All right, it looks like we're live on YouTube. Thanks everyone for joining. It's good to see a lot of you folks here. Yeah, it's exciting to have our friends from Altinity. We have the CEO, Robert Hodges online, and along with my colleagues, Igor and Adnan. So we'll talk about how you can build a fast data stack with open source tools like Clickhouse and Cube. So let's advance to the next slide, Adnan, if you don't mind. Just a quick couple of reminders. We do have a code of conduct. You know, if you like to see more details, you can check out our repo. Obviously, during all of our events, whether it's in person or virtual, we like to have maintain a friendly community. So just a quick reminder. And the next slide, just some quick notes on this webinar. If you have any questions during the session, I mean, you don't need to wait until like the formal Q&A session. Feel free to type your questions in the Q&A tab. I'll be monitoring the chats as well, but it's helpful to have your questions in the Q&A so we can keep track of which questions have been answered. And our slides and video will be posted on our event page, and I assume the same will happen on your side too, Robert, so that you don't necessarily need to take like a furious notes. Like if you want to come back to the recording and the slides, that will be available after the event, and we'll have a post-event survey that's going to be about 5 questions, and let us know how we did and help us improve our events. I mean, both for us and the Altinity team. And just a quick reminder, we have another workshop next week about headless BI and streaming data support like SQL DB. So that's at 9 a.m. Pacific time, a week from today. You'll find more details at the event page. And I think the next page is just a final slide for me. We've had other workshop over the past week. If you happen to miss it, you can go to the events page to find the slides and the recordings. I think the one we had a couple of days ago, we're still waiting for the recording, so you might have to wait a day or two, but we'll have it up and on the event pages soon. So with that, I think I'm going to turn things over to you, Adnan. You'll talk about some of the setup that people may look at, or the details on some of the demos that you'll be going over today. So.
Yeah, definitely. It's a great intro. Thank you, Ray. Yeah, so let me just go ahead and start with the customary intro to pretty much every webinar and workshop we've been doing so far. And that's just to run through the quick rundown of what we will be talking about today and what you will learn today out of this webinar. So we will go through building quick on analytics with Clickhouse, and we'll also hear about data replication between MySQL and Clickhouse, and that's something that Robert will go into in more detail. And then from there, we're going to explain how to integrate multiple data sources into Cube and with Cube. So we're going to take both MySQL and Clickhouse, integrate them with Cube, and then use Cube's APIs that are exposed by default, and use that for data visualization. And obviously, those are the 4 main key sections that we will be covering. And then lastly, we're going to have a Q&A at the end for any questions that you might have. If you have something but you don't want to interrupt or wait for the end, you can always answer or ask the questions in the Q&A tab here in Zoom. So yeah, let's just run through the prerequisites really, really quickly. First and foremost, you do need a Clickhouse setup, so you can use Altinity Cloud and run a Clickhouse instance there, or you can just use a demo instance. If you don't want to set something up, you can use the demo instance that's provided. We've also used this demo instance for the samples and all of the demos that we're going to be showing today. So whichever is your preference, you can go ahead and use. And then regarding the prep guide and the code samples, you can obviously go in and check those out and right away or during the presentation itself. If you did check them out beforehand, even better, but because then you're going to be ready to actually follow along the live demo and gain a bit more knowledge there. But yeah, so the goal in itself for this workshop is to learn how to build lightning quick open source data apps by using Clickhouse and Cube. So yeah, from there, I would like to introduce Robert from Altinity and let him take the mic for the next portion of this webinar. So yeah, Robert.
Great. Thank you, Adnan, and thank you, Ray. It's just a real pleasure to be attending today, and thank you for making this possible. So next slide is that, or this, actually the previous slide, let me just talk about that for a second. We love ClickHouse. We've been around since 2017. ClickHouse is the best analytic database I've ever worked with. In fact, it's one of the best databases of the 20 or so I've worked with over my career. So we are big on ClickHouse, and if you go to the next slide, let me tell you what we do. So we basically help enterprise users run ClickHouse anywhere they want. Obviously, a lot of people want to run in the cloud. So we have something called Altinity.cloud. That was the first ClickHouse service available in Amazon, also the first in GCP. Among other interesting things that it can do is it can actually run, it can now run ClickHouse in your own private cloud. So for example, if you have a VPC in Amazon and you'd like to run it there, we can drill in and manage it there. Be happy to talk about that later. We also do enterprise support. We actually started out as an open source service bureau. So we do standard support for people who run ClickHouse on-prem or self-managed. We have the companies range from tiny startups all the way to some very, very famous companies that everybody has heard of. We also do builds of Altinity, of ClickHouse. I'll talk about those in a minute. And then we provide training and loads of content. If you're into ClickHouse, you may have seen videos that we've done where this is something we spend a great deal of time on. Next slide, please. Okay, in case you don't know what ClickHouse is, I'd like to take a minute and just tell you. So it's a SQL data warehouse. By data warehouse, we mean a database that is designed to read large amounts of data and provide answers very quickly. So you can think of it in a way as being a bit like MySQL, only designed to read large amounts of data. So like MySQL, it understands SQL. Like MySQL, it's open source. In the case of ClickHouse, it's Apache 2.0. Like MySQL, it runs pretty much anywhere. So it can literally run on anything from an Android phone all the way up to clusters in the cloud or Kubernetes with hundreds of nodes. Unlike MySQL, though, it has some special features designed to read data very quickly. It has what's called a shared nothing architecture, which means that we have a set of nodes connected by a network, each with attached storage. This is a traditional data warehouse architecture. ClickHouse is actually going to a decoupled compute and storage architecture, but it's sort of a work in progress at this point. ClickHouse stores data in columns. I'll talk about that and why that's important. And it's also capable of parallel and vectorized execution. Vectorized execution means that we treat data as arrays. We push them into memory. We then load them onto the CPU. Where possible, we use SIMD instructions to process them multiple items in parallel. And then finally, it scales extremely well. It runs great on a laptop, but there are many systems that with ClickHouse that operate on tens of petabytes of data. So as a result of all these features and being open source, it's become the #1 engine for what we call real-time analytics, which is where you have a lot of data arriving fast and you need to get answers quickly. Next slide, please. So I told you what ClickHouse is. Let me tell you what it's not. So I said it was like MySQL, but it is not MySQL. There's a really big difference here. And this is one of the things we want to highlight today in today's presentation. ClickHouse doesn't have transactions, full ACID transactions. Updates are very slow. If you were running an e-commerce site, you would not want to use ClickHouse for it. It would lose your data and it would have low performance. It's also not Snowflake. So you can think of Snowflake as a database that is very general purpose, can operate on large numbers of tables in a single query, and those tables can be very large. It has very strong SQL standard or standard SQL support. ClickHouse is more like a race car. It has a slightly different dialect of SQL from many other databases, and it is designed for speed. So getting answers literally in milliseconds or tens of milliseconds, even in cases where you have trillions of rows that you need to look at. And then finally, it's not Redis. So it is Redis is often used to store session data on websites or for online services. ClickHouse doesn't do that. It's designed to read large blocks of data for a few users at a time, not tens of thousands or hundreds of thousands. Next slide. So let's get into what ClickHouse is really good at then, which is running queries on large data sets. So this is a typical ClickHouse query. If you know SQL, you'll notice that we don't do anything unusual here. In fact, when it comes to select statements, pretty much everything that you're familiar with in ClickHouse, including many of the analytic functions, is supported. Will be there and work well in ClickHouse. So, for example, what we're doing here in this query is we're trying to find out information about airline on-time behavior. This is using a well-known data set called on-time data that's provided by the U.S. government. There's a row in it for every single airplane or every single hop that an airplane takes during the day. What we're asking is which of the airlines in the year 2017 had the most cancellations. So we can select. We have what are called dimensions. These are the things that we're interested in. The way that we group the data. We have aggregates or measurements, as they're called here. These are things that summarize the data in ways that make it interesting and easy for humans to grasp. We have a filter that restricts it to a single year. And then we have a filter on the measurement. So once we're done, excuse me, to try and to knock out rows that have low values. So, and then of course to sort it. These are all things where if you've used any other analytic database, this stuff would look pretty familiar. Can we go to the next slide? So what is interesting about ClickHouse as an analytic database is how it stores the data. This is where we differ fundamentally from MySQL. In MySQL or Postgres or most other conventional relational databases, the data is stored in rows. So that is to say that if you had a flight, all the data in that record would be stored in a single row, presumably on a single block in storage. In ClickHouse, we store the columns. So if you go in and actually look at the underlying file system, you will see 2 files for every column in your table. And you can think of those as basically being like arrays. And those files are sorted so that to give an ordering so that we can now match the columns, the cell values in each of the columns and effectively select out rows. This sorting is very important because it also determines how quickly we can access data. So for example, if we did wish to, for example, have a lot of tenants in here, we would typically sort the data so that the tenants are the first thing we sort by, and that would neatly split up the data across tenants. Let's go to the next slide. So what I'd like to show here is the effect of columnar storage because it's actually astounding how big a difference it can actually make. So what this is a series, imagine this is a series of globes. So or spheres, if you will, that represent the volume of data that you would have to select to answer that query. If you were running in MySQL and you had the data loaded in, it might take up, say, 59 gigabytes. It did at one time, and that's when I ran these measurements. In the case of MySQL, we'd have to read every single column because we're asking a question about 3 columns, but we would drag in all the rest of the rows. This is a big table. And so we would end up reading 59 gigs of data. Now, in ClickHouse, because it's a column store, we're right away going to read a much smaller amount of data because there's only 3 columns. And it turns out that is almost exactly 3% of the data in this example. And so it's about 1.7 gigs. But the other thing is that because we're in columns, and those columns are compressed, it means we read a vastly smaller amount of data. And one of the things about storing data in columns, because it's now all the same data type and often ordered in a favorable way, you get huge compression values. So you can see that the drop in the amount of data that we have to read is about a factor of 100. But it's even better than that because ClickHouse not only reads a smaller number of columns, and those columns are highly compressed, it can read them in parallel. So when you actually run the query, we're going to have 8 threads which are going to read this data, and as a result, each thread only reads 2.6 megabytes. That's actually, when you look at how much data each thread reads, that's 23,000 times less data than MySQL, than the single MySQL thread would have to read. And so as a result, ClickHouse queries are phenomenally fast. Let's just go back. If we go to the next slide, I can illustrate that. So here's that same query again. And what we see here is the result of running that query. And in fact, we're going to end up, we have a filter here. So it's reducing the amount of data we have to read. This is about a 200 million row data set, but it comes back in 45 milliseconds. We didn't do anything really special to do this. ClickHouse is just extremely fast. And you can see the effective rate that it's scanning rows is on the order of 240 milliseconds, rows per second. So this, as a result, is the reason why people like to put data in ClickHouse for running analytic queries. Great. Let's go ahead and show you how to get started with ClickHouse. So first thing you do, if you're just beginning to use ClickHouse for yourself, you can just install it on your laptop. So, and that's typically what I would do, or you can stick it on a VM. You can also, of course, put it in the cloud. So Altinity.cloud is a great place to start. There are also several other services that offer this as well. If you're doing it on your laptop, let's say you're running Ubuntu, it's very simple. All you do is just say, point to the correct repo, and then just use apt install. So this first command pulls down the ClickHouse server and the ClickHouse client, and the second command is actually going to start it. So these are 2 commands that you need to pull a version of ClickHouse. There's a few other commands that you can read up in the documentation that show you how to get connected to the repo. If you're installing the software, it's important to notice that there are 2 places that you can get the ClickHouse software. The ClickHouse community builds are have been available for years. Every month there is a new version of ClickHouse, and every 6 months there's what's called a long-time support build. And so that is one that the community supports for up to a year. They come out typically in March and August. The other builds that are available, and then the monthly builds are only supported for basically a few months at most. Altinity stable builds are also based on completely open source ClickHouse. The difference is that we only build the LTS, the long-term support builds, but then we provide 3 years of support. So for example, the 21.8 LTS build from last year, it's been supported for over a year. The support will run out in 2024. So these are your choices. Of course, if you're running in the cloud, there are other versions. In Altinity.cloud, you can pick any of these. You can run the ClickHouse community builds, or you can run Altinity stable builds. It's up to you. Let's go to the next slide. So once you have the software available, the next thing you're going to do is create a table. So ClickHouse has a create table command. One thing that you learn in ClickHouse is we tend to use different names for the data types, but they're pretty easy to understand. Actually, I believe the SQL, the ANSI names are supported, but I've been using it for so long that I don't use them. I just use the native types, but they correspond pretty well in general to the normal SQL types. The place where ClickHouse is really different is the table engines. So like MySQL, we have a notion of table engines, but the difference is that in ClickHouse, we have an enormous number of them. There's probably 40 or 50. There's certainly dozens. The most common table type or engine that you're going to use is called merge tree, which is actually a family of engines, but they are designed for big data. And they have a couple of key things that you're always going to have. First of all, they're going to have a partition by expression, which is to tell ClickHouse how to break the table up into reasonably sized pieces. We call these parts. And then the other thing is primary key and order by. So primary key, this is not like a primary key in the sense that MySQL or Postgres would talk about it. It's actually what's called a sparse index that allows us to locate rows very quickly. It's designed to fit entirely in memory. It doesn't assure the referential integrity or uniqueness, but that's put in automatically. And then your order by is also is telling how to sort the data. In ClickHouse and using merge tree, you must, the primary key must be a prefix of this order by. And in fact, you can even leave it out. You can just say order by, in which case the primary key will exactly match. What this does is it sorts things by carriers, so by airlines, and it supports within airlines the rows by flight date and by their departure time. So what we'll find if we go into the data is we have these nice big contiguous sections that answer questions for individual airlines very, very quickly. This is a typical setup that you would use for multi-tenant data. You would do it the same way. Imagine the carriers or tenants, you would do this. Next slide, please. So how do you load the data? Well, normally you'd think inserts if you're used to Postgres or MySQL. In ClickHouse, we use what are called input formats, and we tend to load data in bulk. So this particular data set is loaded from CSV, so comma separated values. I have an example of one of the files. This is what we call it, the input format is CSV with names. And you go ahead and cat that into the ClickHouse client, which is the command line interface to ClickHouse. Tell the database name that you're putting into, and then you say, oops, looks like there's a typo here. Sorry, it should be on time. Anyways, you'll say insert into on time format CSV with names, and you will see it will just load the data. You can actually load millions of rows like this from a single file. You can load it in parallel. ClickHouse typically can load anywhere from, for a small instance, can still load data at a couple million rows a second, all the way up. I've gotten as many as 80 million rows a second. It is really, really fast. Let's go to the next slide. So one of the things we do is make data smaller with compression. I mentioned that already as being really important to the results. Here's a little bit more detail about how it works. So ClickHouse by default uses LZ4 on all the columns. So if you get typically fairly good compression without doing anything, the sort order can be very important for compression. The less variation there is between successive values, the better it is. So for example, here's, we see that this particular example, they aren't actually sorted, but if we were to sort that, we could get even better, levels of compression. So, and what you can do is, in addition to sorting it, you can also use higher levels of compression like ZSTD. So that's available. It's slower to compress, and so you have to ask for it, but it can really hammer the data down and make it very small. There's one more feature, which we'll show on the next slide, that, there we go, thank you, that integrates super well with compression, and that's codecs. So the idea with a codec is compression doesn't know anything about your data, it just sees it as bits, and it recognizes patterns and tries to squeeze them out into smaller, or squeeze them down into smaller patterns. Codecs actually know the data type. So for example, they know you're dealing with an integer, or they know you're dealing with a string. And what they will do is convert that to a smaller representation. Example, those tail numbers that I just showed you, those are the identifiers for jets, or for commercial aircraft. We can put them through a codec called low cardinality encoding. And what it does is, instead of storing 6 characters and 6 bytes, it turns it into an integer. And so it's basically a lookup table. You get a smaller value, and then you turn that over to ZSTD compression, and it gets really small. So this is an additional thing that you can do. It's something you have to ask for. ClickHouse doesn't do it automatically, but as a result, you can sometimes get enormous levels of compression, so that you may start with some string value, but you could actually get it, compress it 99%. That's not uncommon. Next slide, please. Just examples of how you do that in your code, because this is something that you need to do. With ClickHouse, you don't have to get everything right up front. It is very easy to alter the tables, even when you have traffic on them. These are examples of how you would add, for example, change the tail num column to use low cardinality. Another example of changing the year column to use a codec called double delta. that stores the slope of the slope. So very, very tiny amount of information if you have a slowly increasing integer. And then you can force ClickHouse to actually change them on disk with that last command. So these are things that as you're developing an application with ClickHouse, you'll typically be tweaking these and improving the performance as you go along. Next slide. You can always add more compute. So ClickHouse by default, in the query will take half the vCPUs that are available if you're running in the cloud. You can control it with a setting called max threads. This is just an example of running a query where we actually change the max threads, go from 2 to 4 to 6 to 8. You can see that from 2 to 4, you get a big jump. Later on, you get less. And that's because we have to do some other stuff that can't be parallelized, like merging and sorting. Question here: does ZSDD improve read speed? Yes, the answer here is absolutely. And the reason it improves the speed of reads is it reduces I/O. There's just less stuff we have to get on the disk, and the cost of decompressing is relatively small compared to the cost of reading it. So that is, there is an effect that this allows you, as the questioner asked. The important thing here is, actually, can I see that? Let me see the question again. I just want to make sure I've got this. Yeah, so saving money on storage is kind of a secondary thing for most people, unless they have very large amounts of data. The key thing that you're looking to do is to reduce I/O. That is your number one problem. In order to, you want to read fewer rows, you want to read fewer bytes in those rows. If you can do that, your queries become blindingly fast. And what it does is it makes it very, very efficient to do things where you have to scan all the values in a column, in a table, or a large subsection of them. Let's see. Oh, here's a question about joins. Yes, so ClickHouse does do joins. Important. In fact, I did a whole talk about this, but very briefly, in data warehouses, if you're looking for millisecond behavior, the best thing to do, or millisecond response, the best thing is put everything in a big table. And what that means is actually having a lot of columns, so you denormalize. It also means you put multiple entities. Like if you have different event types coming in, you just represent them all in the same table. And ClickHouse is very good at dealing with this and has a number of great features that can simulate joins in this large table. It's probably more, I'd be happy to go into it in later depth, but I want to make sure we get to other topics. Okay, next slide. Okay, let me talk about a couple final things. So we've mentioned that one of the ways that you can build great systems is that you can combine transaction processing, OLTP, and the analytics, online analytic processing, or OLAP, in a single application. There's a couple different design patterns for this. A very common one is just to have two separate databases to do it. You use MySQL for transaction processing, and then your analytic data, for example, network flow logs, if that's what you're doing, they just go live in ClickHouse. They're two completely separate sets of data. You just have one application that talks to both of them. The other way you can do it, though, which is something that's increasingly of interest, is you could actually store all your transaction data in MySQL, and then you can mirror it to a data warehouse like ClickHouse. The reason you would do that is because you want to ask analytic questions on the data. Like, for example, where did people drop out of the funnel when they were on my website? Why didn't they buy something? What was it that blocked them? What offers could I have given them? These are things that an analytic database can answer very quickly. And so what we want to do is take the transaction data and we mirror it. In other words, we make a continuous copy of it and put it in ClickHouse, and then you can go ask those questions there. So if we can skip to the last slide, this is an example of how to implement this that we are working on right now. My colleague Kanthi Subramanian, who is also on this call, has done most of the heavy lifting on this. but this is an example of an actual deployed system that went production recently, where the transaction data is stored in Amazon Aurora. So in MySQL, their analytic database is Altinity Cloud. And what we have built is introduced new software that combines the Debezium MySQL connector. This can read the MySQL bin log, put the data into Kafka or any Kafka compliant or event stream, and then feed it into Altinity.cloud using something called the Clickhouse sync connector, which Kanthi wrote. So this allows you to have literally up to the minute or even up to the second data in Altinity.cloud that's a mirror image copy of the data that you had over in Aurora. So with that, this part is done. I'll go ahead and
Cool.
turn it over. There is
Yeah.
one question here. If Ray, do you mind if I answer that, or would you like me to just?
Yeah. I think I actually goofed. Like I marked it as done, but it was the multi-tenancy question from Tom.
Yes.
So go ahead, please.
Yeah. So there's a question. Okay, great question here. This is one that comes up. This is the reason I want to answer it. So the question is, for multi-tenancy where you never expect to aggregate across tenants, would it make sense to partition by carrier and flight date rather than just a time partitioning in order by carrier? We get this question a lot, and the idea is you'd think that it would make sense to have your carrier split into separate parts in the table. The problem is they're very different sizes. So 1/7 of the data in this data set belongs to Southwest Airlines. And then we have little podunk airlines, which might have like a few hundred rows. So what you'll end up with is a huge disparity in the size of the parts. And in large systems, that becomes very difficult to manage and very inefficient. Instead, what you do in ClickHouse for multi-tenant systems, the best practice is to divide by something like time, or partition by time, because that will split the data into more or less evenly sized chunks that you can also drop easily. Like let's say you get whole 365 days worth of data, and then within those parts you order first by the carrier, by the tenant, and that results in contiguous sections of data for each tenant. So that's really a best practice for handling multi-tenant data in ClickHouse. And with that, I hope this has been helpful. I'll turn it back over to Adnan.
Yeah, this is great. Very informative. I really like listening to it. And yeah, now we're going to jump into the headless BI part, where we're going to hook into the data that Robert was just talking about. So yeah, with that, let's just jump right in. So Cube, as you know, and for you that haven't seen us before, is we are an API first headless BI. So what does that even mean? What does headless BI mean? Well, it's a rather new concept in the space, in the data space. But what it is, it's quite basically a metrics layer. You can think of it as the central metrics layer where you define your business logic, or your business metrics, so to say. So you can use those two terms, whichever one you like more: headless BI, metrics layer, centralized metrics layer. All of those things mean the same thing. And what do they consist of? So what does a headless BI consist of? And we have four main pillars that we're going to talk about. And they are data modeling, access control, caching, and APIs. So these are the four main pillars you need to remember. First and foremost, we have data modeling, and that's used for modeling the raw data into business definitions. So we call them data schemas as well inside of Cube, and you're going to see that in a moment as well. Then we have access control, and this can be basically everything from role-based access control to multi-tenancy. And this also includes authentication and everything that goes into the sphere of access control. And then from there, we have a caching layer, and this is used for not just caching identical queries, but also something we call pre-aggregations, which is basically running aggregations ahead of time and physically creating smaller data chunks that we can query much quicker than the raw data itself. And then lastly, of course, we have the API section, the API layer. And that's where we have all of the APIs that are exposed by default that you can query the data directly right from the get-go. So you don't have to develop any middleware API layer or any software of any kind. You just hook in your front-end apps, your BI tools, your whatever you want to use directly into the APIs that we provide you inside of Cube. So this, as you can see, is a bit better, more detailed topological overview, like a layout of what this means, of what it means to have a headless BI, where you do have obviously the data sources on the left side, and you can see that we support dozens of different data sources. We have cloud data warehouses, databases, transactional databases, query engines, and much, much more. And then from there, you can see that the data modeling section is where we define the business definitions, so the data schema. Then we have the access control, then we have the caching section, and then the APIs where we support 3 APIs. We have SQL, REST, and GraphQL. And then on the right-hand side, we have the data consumers. And regarding the demo we're going to be showing today, we will be showing hooking in MySQL and Clickhouse into Cube and editing and writing some cool measures and dimensions inside of the data schema. We're then going to jump into the access control layer and showing you how to use these different data models for different data sources. And we're also going to check out multi-tenancy as well. And then from there, we're going to build a few super simple React apps and hook those up through the REST API to show this data visualized on the front end as well. So we have a lot of things to cover in the next 15 to 20 minutes. So let's just jump in. So the goal is obviously to use 2 different data sources and have them the data seamlessly switch or load the data seamlessly from both of them. We're using Cube as the intermediary metrics layer, as the headless BI. And then we're going to seamlessly load this data into 2 different React apps on the front end by using the REST API. So we're using 2 applications, and we're loading from 2 different databases, and it's all going to be seamless, and it's going to be absolutely beautiful. So this is the rough rundown of what we are building. So we have the 2 data sources on the left-hand side. We're using Cube as the headless BI, and then we're using React for the front end. Now, in a short rundown, as I did explain in the topological explanation, the graph you did see, we will learn 3 main things, and that's data modeling, access control, and APIs. For the data modeling, you learn how to integrate multiple data sources with 1 Cube deployment. And then with the access control, you learn about multi-tenancy, of how you can access different data by using specific JWT tokens. That's also something that is tied to multi-tenancy. And then lastly, we will do some data viz with using the REST API that we get exposed by default inside of Cube. Awesome. So jumping into the first part, let's talk about seamless data integration between these 2 data sources. In this section, we will cover everything regarding the data source and the data model. So we'll talk about data modeling, we'll talk about using these multiple data sources, and we'll talk about multi-tenancy. But before we jump into all of those things, I do want to move over to Cube Cloud really quickly. And I want to show you everything that Robert just now explained regarding how much quicker it is to query Clickhouse versus MySQL. I want to jump in here and show you what that actually looks like in real life. So if you did follow the prep guide, you would have seen the preparation for setting up this Cube deployment, hooking everything up to the Clickhouse demo database and on-time table that we're going to be using. Let me actually show you this in the data model. So here in the schema section on the left side, we have an on-time.js file, which is basically the data schema for the table inside of Clickhouse that we're going to use. So we're using the on-time, which is the same data set that Robert was just now explaining regarding flights and carriers. So we have a data model here. And as you can see, just as Robert just mentioned, measures and dimensions, we have these definitions already defined in our schema because that's something Cube provides out of the box. Once you do connect the data source, it lets you automatically generate these schema files. It quite literally generates them from the table. So this cube that we have here is mapped to a table inside of Clickhouse. And then we have the measures and the dimensions, where the dimensions are mapped to a column, And then we have the measures that are quite literally aggregates of a certain column. So if you're comparing what I'm saying right now to what Robert was just explaining, it's quite literally the same thing. So yeah, so it's very exciting to see how everything is kind of falling together like Legos. But yeah, so back to the playground. I want to show you just a quick query from this data set. So let's just query the count, and let's just use the day of week dimension to get a nice grouping by the day of week. So this is a list of per day. We have well over almost 30 million flights that have taken place. So obviously we can also run another one where we say, okay, so we want to add a filter where we only want to see the flights per day, but that have a departure delay of more than 10 minutes. So if you run that again, once again, it is lightning quick. So this runs in well under half a second. So this is, I think it was roughly 200 milliseconds, if we can check that. Yeah, roughly 100 milliseconds. So as you can see, it is absolutely lightning quick. Running this in MySQL would be very painful. But yeah, with that, you've seen a quick rundown of how quick this is, and a hands-on, pretty much with your own eyes, seeing how basically everything that Robert was talking about, you can see how it acts in the wild, so to say. So yeah, so from there, I would like to jump back into the slides and just go over the data modeling. I mentioned briefly data modeling and how we map the cubes and the schema files to a table in Clickhouse. And let me go in a bit more depth here. That's basically what data modeling is. We're mapping the tables to the OLAP cubes, and then we're using the table columns that are mapped to dimensions. In that way, a dimension is an attribute that's related to a measure, where the measure is actually an aggregation of a certain dimension. And I think the best way of explaining that is by adding something we call custom measures. So you can, of course, always go in and add in custom measures as you so please and as you so like. And here's an example of that. Let's say I want to add a measure where I want to get the average departure delay for all of these flights. Well, yeah, that's pretty easy. I can select the type to be average, and I can add in the SQL and say, okay, for this particular dimension, I want to run the average count or calculate the average. And as you can see, this quite literally is an aggregate function. So it's very straightforward when you're looking at the syntax itself. The same thing goes if you want to add a more complex measure. For this measure, I want to add a percentage. So I want to have a percentage format where I'm calculating, okay, so I want the average percentage of the departure delays that were above 10 minutes. So this is a more complex measure, but it's also very, very straightforward and simple to add into your data model inside of your data schema in Cube. Yeah, let me actually go ahead and show you firsthand how you go about doing that. Conveniently enough, I have this piece of code just commented out. So if I do jump into the development mode, and this is going to let me edit this file. And if I go ahead and just comment this in, I save this up. This is a really convenient feature we have in Cube Cloud where we have this version control. So now if I want to try out this change before I go ahead and commit and push this to my master branch, I can just jump in back to the playground here and just run this query before I actually go ahead and commit. So here we have it. So it's the we're looking for the average departure delay, and we want to once again use the carrier as the dimension. Awesome. So now we're getting a nice list of the average departure delay for every single carrier. And then again, if I want to do the same, but I also want to add a time dimension where I want to see what that looks like per year, I can do that as well. But I think what I think is more important here is to show you the percentage. If I jump in here and say, okay, so I want to grab the average departure delay that's greater than 10 minutes, and then I want that percentage. Once again, grouping it by carrier, I can do that as well. And here I'm getting to the bar here. Well, actually, let me do the pivot it a bit like that. There we go. So now again, I'm getting the same data back, but It's nicely formatted. For every carrier, I can see a percentage of the flights that were delayed more than 10 minutes. And this is, as you can see, this is returning in 200 milliseconds. And this is quite a complicated query. We can even check the query. We can go into the SQL tab here and you can see, okay, so we're running, obviously you can copy this right into your editor and run this directly against ClickHouse and you're going to get the same result set back, which is also very convenient because we provide that inside of Cube as well. So yeah, so you can see that this is not a super straightforward query. For me at least, it's not really logical for it to be returning just this quickly. But after everything Robert explained, I can kind of finally understand why. So yes, I think it's incredibly cool how quickly this works. So yeah, with that, I do want to jump back into the slides here and just take a second to talk about the general layout of how many data sources we do support. We do have dozens of data sources that we do support. So one of them is obviously ClickHouse. We have Postgres. We have a ton of different data sources. And they range from data warehouses like BigQuery. We have transactional databases, query engines. We even have streaming databases like Kafka and KSQL. That's something we just released a few weeks ago as well. So it's right across the board. Pretty much any database you want to use is something that's viable. But today we really only care about MySQL and ClickHouse. And when you're thinking about using two different data sources and loading data into Cube, you can think of it, okay, so I'm just going to create two different deployments, set up two different deployments, and I have two different APIs, and I'm loading the data that way. Well, no, that's not really the best way. That's not something we want to encourage you to do. The better way is to either use the multiple data sources feature by using the data source attribute, or setting up multi-tenancy with something we call security context, which is basically the context that's read from the JWT token you provide to the API itself. Now, regarding the multiple data sources, this is very, very convenient if you have multiple schema files. So if you have multiple schema files that map to different tables in either of your data sources, this is definitely the way to go, where you use a data source property. And that's something I want to show you now real quick in this demo. Conveniently enough, I'll just exit the dev mode and I'll change to a branch that I have ready for this. So we don't have to wait for all of this to get loaded and waste time there. So yes, as you can see in the schema files here, I do have one file that's called on-time MySQL, and I have this data source equals to MySQL here. This file is pretty much entirely the same as this on-time file. So I'll literally just clone the file, added in this data source, and then I did the same thing for the ClickHouse one, and I added in a data source for ClickHouse. And once I did that, I can go into the Cube.js config, add in my both the ClickHouse host and all the connection information, as well as the MySQL connection information. And then I can configure the driver factory, where I can say, if the data source from the data schema that I'm reading is equal to MySQL, then let's load this data source connection. Otherwise, if it's not, if it's equal to the ClickHouse one, load in the ClickHouse one. So it's a very straightforward configuration. Like it's 25 lines of code or so. Very straightforward, very logical how this gets configured. And now if I jump into the playground, because I have these two physically separate data schema files, I can go ahead and right here you see I'm querying, I'm grabbing the measure for ClickHouse. Average departure delay is greater than 10 minutes. So it's the same measure, but now I'm querying, I'm getting this this measure from the data source, from the data schema that's connected to ClickHouse. And once again, I can go ahead and run this, and this is going to take 200 milliseconds, give or take. If I run this same query against MySQL, so this is the same query against MySQL, to not wait for like 10 minutes or so, let's run this for a time frame that has roughly 7 days. So yeah, so this took obviously longer to run against MySQL for a 7-day period than it did for ClickHouse to run against the entire data set. If I try doing this against MySQL, we can even try as to by year. to kind of not murder it. This is going to take roughly 10 minutes. But it's that saying, like, you use the tool that's like, you use the hammer to fix the problem you have. Like, MySQL is obviously not built for this. ClickHouse is, as Robert did explain, MySQL is built for inserts and updates and transactions, and that's just the way it is. But yeah, so this is the way that we do suggest you set up multiple data sources within Cube, and then you can quite literally seamlessly query data either from ClickHouse or MySQL based on your needs. Yeah, so now if we don't have any questions, I can also move on to the multi-tenancy part. I see that we don't have any questions. Awesome, so we can just move on then. Perfect. So now the difference between using multiple data sources and multi-tenancy is because when you want to use multi-tenancy, you might not want to have physically separate data schema files. This means that with multi-tenancy, with a multi-tenant setup, you can use the same data schema file. You can have an identical data schema file, but fetch data from the data source based on the token you provide. So let me explain how that works. It works through something we call security context, and it decodes the payload from a JWT token that you provide. Let me go in and show you that demo really quickly here as well. So now obviously I have a super simple demo ready here, so we don't have to wait for this to load. Now, once again, let me jump into the schema file. And as you can see here, now I have just the one schema file again, and I don't have a data source parameter here inside our cube. But the difference being in the Cube.js config file is that instead of using the initial config, I'm going to use a driver factory config based on the security context. So this is going to look for a data source parameter inside of the security context instead. This means that once the security context is decoded, so once the JWT token is decoded, it's going to want to look for a data source. And if that data source is equal to MySQL, we're loading this data source. If it's equal to ClickHouse, we're loading ClickHouse. Otherwise, we're just going to throw an error and ask for a valid security context. So now if I do jump into the playground once again, and let me find a query. So yeah, so here's a query that we can run. And once again, we have the same data schema file, and we're running it, we're using the time dimension, and we're running this custom time frame. Now, if I do jump into the security context, if I don't set this data source, let me just go ahead and delete it and save this up. This is going to throw an error. Okay, so we don't have a data source, so you can't access the data at all. Cool, let me go ahead and get this added in once again. And if I save this up, it's not going to argue with me. Awesome. So now if I do run this, this is going to read the JWT token, the payload, and it's going to return the data from MySQL. Again, if I change this up and I want to read from ClickHouse, I can save that up, and then I could run this query again, and this time it's pulling from ClickHouse. Now, if you don't believe me, we can try running that. Actually, let's just remove the time dimension. Actually, let's put it back in and put it all time, and let's do year. And if I run this again, you obviously know this from ClickHouse because it's absolutely light and quick. But if I change this over to MySQL, I save this up, this is going to take ages once again. So yeah, so this is a quick rundown of the, I'm going to say an equivalent of that in between using the multiple data sources and or using multi-tenancy. It's basically the same outcome, but you can pick whichever solution works best for you. Sweet. So that's that regarding the back end part. I'm going to say the data source and data model part. Now we're going to move into exposing the APIs and then hooking everything up to the React apps on the front end. So yes, that's what we're going to cover. We're going to cover the GraphQL, SQL, and REST APIs that Cube does expose by default. And then we're just going to jump into building the React apps with Cube's REST API. Now, Cube does provide these APIs by default, which is absolutely great because you don't need to develop any custom data provider. You don't need to build anything, any middleware of any sorts. Everything is baked into Cube. So you can quite literally just choose any API you want. And what's amazing from that side is because you have all of these 3 APIs connected to the same location, it's literally agnostic regarding the data that you get back. You can calling any API will return the identical data, so you don't have to worry about anything. It's all handled for you. So if you want to use BI tools or data exploration tools, you can use those with the SQL API just fine, just as you would connect, for example, Superset to a Postgres database or to Clickhouse or to whatever else. Same goes for data notebooks. They're going to work just fine because we have this lovely SQL API. Then if you want to use front-end tools, low-code tools like Retool or whatever else, or front-end integrations like React, everything is going to work out of the box because we have a JSON query that you quite literally pass in to the API request, the REST API request, or the GraphQL API if you still want, and you get the response back. And yeah, with that, we can jump into the actual layout of our application. So once again, we're using Clickhouse in Altinity Cloud. We're using MySQL on AWS. We're loading the data into Cube, and then we're fetching that data through a REST API with React from Cube and building a database on the front end. Sweet. So let me just jump into that demo. What I want to show you first and foremost what those apps look like here finished, and then I'm going to walk you through. We don't have so much time, but I'm going to walk you through quickly the code of how everything works. So now, if I do run let's say run a query for 1988 for July, we're going to see that this particular month and this year, it has been cached by Cube's caching layer because I've been running this query periodically just to make sure for the demo purposes that it has been cached. But if we run another month that hasn't been cached, let's say June, we're going to see, okay, obviously this is going to take a moment to return this data back. Hopefully within a few seconds, we're gonna get it back. And to make sure you understand the difference, you can see here inside of the data, you see on time underscore Clickhouse. This is literally pulling the data from the data model that was connected, that we explicitly made sure was connected to the Clickhouse data source. There we go. So 30 seconds in, we're getting a response from MySQL. And as you can see, it's using the on time underscore MySQL data schema file, just as I showed in the demo inside of Cube as well. Now, this is just a simple demo for using the multiple data sources. But if we want to use the multi-tenancy, we have this demo here where we can, let's say we want to use Clickhouse to fetch data from May. And I just conveniently wanted to place this auth token here. If we actually grab this and put this inside of the JWT debugger here, we can actually see that the data source indeed is Clickhouse. But if we do change it, and let's say MySQL for the same month, we can see that the token did change. So now if we go ahead and decode it, you'll see that, yep, indeed, it does have MySQL as the data source. Obviously, again, this month was cached. If we take another month that's not cached, this is going to take a moment again to return back the data. Cool. So now I guess if we don't have any questions and we're running quite low on time.
Yeah, I think there is one question, Adnan, I don't know if you've seen it, from Tom on the multi-tenancy demo.
Oh yeah, obviously this multi-tenancy demo I did explain isn't exactly the same as Robert's, but the logic of implementing this multi-tenancy inside of Cube can be applied the same way. So this was just a simple demo to keep the two demos that I was showing kind of in the same ballpark, so that you guys would understand it as easy as possible. But definitely you can implement the multi-tenancy whichever way you want. You can use whichever, let me actually go back to that I wanted to show inside of here. So you can basically, for the JWT token, for your security context, you can add this as a tenant. So let's say you have tenant ID, and you can set this to whichever ID, it doesn't really matter. And what that does is that once you do jump into the Cube, the Cube configuration here, you're going to use something we call a query rewrite. It's actually let me go into the documentation and I can show you more detailed. And what's amazing with the query rewrite is that you can decide which data here we go. So you can decide which data is going to be sent back to the initial query based on the security context. So in this example, we're using user ID. So that would mean if we set a user ID in the playground in the security context like this, we say user ID equals to 1. This would mean that it would read this user ID from the security context and then make sure to add this filter, which would then define which data set would be returned in this query. So by using this query rewrite, that will basically make it possible to handle the tenant-based access control just as far as I understand, the same way that Robert explained it.
Yeah, if I can jump in, Adnan, that's correct. And one of the things, even though you have the data in a single database in Clickhouse, it can often make sense to have multiple users accessing it. Clickhouse has a really cool feature called row policies, which allow you to restrict the data that a particular tenant or user can see. So you could basically set these up. You have the data all in one table, but you could set up row policies that say, hey, user 1 gets to see only the data from user 1, user 2 gets to see the data only from user 2. This is a way to separate things out.
Yeah, and the same logic applies to this query rewrite method that we do have inside of Cube. So you can, in the same way, filter out or filter in just the rows that you want to pick. Also, I think that would be we did actually, if you want to know how this works in Cube, we did a multi-tenancy workshop a few months ago where we really took a solid hour and a half to go into all of these multi-tenancy configurations. And I would love to share that after this webinar as well for everybody to check out, because I think that will be very, very informative for you that want to build out multi-tenancy, especially with these tenants that you were just explaining and in Tom's question.
Yeah, we're a couple minutes over. I appreciate people staying on. Let's answer just one more question from Will. Does the tenant SQL query rewrite work for Cube's SQL API as well?
Yep, it does. Let me just find that documentation page as well. Yeah. SQL API, and actually not, that's not the one. It does work, but the config is a bit different. You're not using the security context the same way you're using for a REST API. Let me find the documentation page, and then we can.
Yeah, if you don't mind, I can quickly chime in here. So yeah, this is somewhere in the SQL API docs, but the gist is for the SQL API, the multi-tenancy implementation, or the security context passage would be that there will be an additional column -- user available in every cube, and you can pass your security context through the where statement that references that column, and basically that allows you to catch that meta information, that security context in the query rewrite function or wherever you want to, and well, perform your query rewrites with that. So yeah, obviously JSON web tokens, they're not available when SQL API is used, but this -- cube service column, that really helps. And I guess you can quickly kind of build the whole picture with that, right? So this is actually a very widely adopted pattern where you can have this mandatory filters on some dashboards, right? So your BI tool might be automatically adding some filters. So you can save this -- user equals something expression in that filter, and make sure that a dashboard or data notebook built for a particular tenant would have access to the data of that particular tenant and that only, right? So this is a way to use this, and hopefully that answers the question.
Yeah, and Let me also add in the docs page here in the response. So,
yep.
So you have a reference, so you can read that as well. So yes, so
awesome.
Exactly what Igor was explaining. We have this double underscore user, and then we have this check SQL auth as well. Sweet.
Cool. Well, thanks everyone for staying. We went 5 minutes over. Hopefully that didn't eat into your like other meeting schedules. Thanks for all the panelists, Robert, Conti from Altinity team joining us, and yeah, we'll look forward to doing more in the future. So
yeah, definitely, this was a lot of fun for me.
Yeah,
I hope you guys
you.
had as lot of fun as I did.
Yeah, great demo. Thank you very much.
cool. All right, have a good rest of your day.
All right.
Cheers.